Good morning, boys. Today we are going to study alternating current. Till now we have gone through electrostatics, capacitance and circuit theory. So in circuit theory whatever we have studied, that was the current or direct current, the direct form of current in which we have to study the current flown from a battery which is unidirectional always. Okay. So this was DC. And now in this chapter we are supposed to study AC. Okay. AC is what? This is the by virtue of electromagnet, not only electrostatic properties of matter but electro as well as magnetic. Okay. So it achieved by virtue of flux linkage or change in flux linkage, flux association. Okay. And this DC was by virtue of this battery, only this battery, the electrostatic property or the energy is stored inside this battery. So in DC what happens, the electron have to travel unidirectional always. Okay. It means if there is an electron, this electron will travel throughout this circuit. So during this travel what will happen, the maximum amount of energy loss will occur. Okay. So there will be huge energy loss. So for preventing this energy loss, the invention of AC happened by Tesla. So in this circuit what happens, a current or electron doesn't travel in unidirectional, but instead of unidirectional it travels in both the directions like to and fro motion. When the positive cycle of battery will occur, it will go in this direction. When negative cycle will occur, it will go in this direction. So it will always moving to and fro on its own position. So if it is not bound to travel from one place to other place, what will happen? Less collisions will happen, less collision, and if the less collision will happen, less heat loss. Okay. So that's why AC have only advantage over DC, that it there there is always a less energy loss occurs in AC. So when nowadays you see in your cities the electricity is transported from very far, it means like I am sitting in the city Delhi, the electricity is transported from Haryana or any city which is 250 around 250 kilometer away situated. Okay. So what happens, since the transportation made easy by AC, we increase the voltage, we transport it from this place to 250 kilometers away in any city. That is only by virtue of AC. If DC, if suppose we are using DC for this transportation, what will happen? The 50% or more than 50% energy will be wasted. Okay. So now what we have to do, if we are still in nowadays we are operating on DC, what we will have to do, we will have to apply or we will have to deploy a electricity plant for every you can say 5 cross 5 kilometer area. Okay. So every, you can say every small pocket, for every small uh, area of population, we have to deploy an new or fresh electricity plant so that we can get the electricity. Okay. This is all about the basic of AC. Now we have to study AC separately. So first, the generation of AC. So it is occur by, suppose this is a north pole of a magnet, this is south pole of a magnet, and we apply a circuit. Okay. This is a coil, and here it will be two joints. this is resistance R, and we will get output from here. So what will happen? This will perform a motion by angular velocity omega. So this is called omega t, omega, or in time t. What will happen? When it will rotate, when will it will start rotating, the flux linkage from north pole to south pole, this will be the direction of magnetic field. This is B, okay, and the area of the coil will always change since it will rotate, okay. So the now how this will happen, the flux will be phi will be B dot A, okay, or since it is dot product, we will write B A cos theta, and on the place of theta we can write B A cos omega t. So phi is equal to B A cos omega t. This is the flux associated with that coil, okay. So now EMF is equal to what? Rate of change of flux, d phi by dt. So B A will be taken as common, the d cos omega t by dt. So B A omega cos, the differentiation of cos omega t will be minus sin omega t, minus sin omega t, okay. E, now E is equal to minus, if the coil have, this is for a standard, if we have considered 1 turn for each turn, if the coil have n number of turns, so n B A omega sin omega t, this is the EMF. So this EMF, this portion is called as E naught. E naught means peak EMF. Peak EMF, the maximum amount of EMS which can occur. So the maximum value of sin omega t can be 1. The maximum value of sin theta is always 1. So if this value will be 1, so this will be the maximum EMF, okay. When the whole value of this maximum, that is called E naught, peak EMF. Now current is what? EMF upon resistance, okay. So what is EMF? We have find B N A omega cos omega t by R, okay, sin omega t by R. Now this will again, this will be peak current, we can say I naught or peak current, okay. So when we'll get peak current, now understand the concept. I is what? I is the function of time. Since current is the function of time, now when in alternate, when the charge, when current will flow, the charge associated with that I is equal to total charge flown is equal to I dt, okay. This is the total charge flown, and current is what? Current is the function of time. When we'll draw the diagram of I versus t, so it will be a sine wave. This is t is equal to 0. Here it will be t by 2, and this is t, and this is current I, okay. I versus t diagram, it will be like a sine wave, okay. So in sine wave, what we one thing we have to study, that sine omega t, the average value of sine omega t or any value of sine theta, the average value in full cycle will be 0 always, okay. The average value of cos omega t and the average value of cos 2 omega t will be equal to the average value of sine 2 omega t will always be 0. Okay, for full cycle, whatever we are writing here, this is for full cycle. And for sine square omega t will be equal to cos square omega t will be 1 by 2. So the average value of square terms of sine and cos will be 1 by 2 for full cycle, and average value of sine omega t, cos 2 omega t, sine 2 omega t without a square, any value of average, any average of any uh, average of sine or cos will be 0. Write it, pause the video and write this value. Okay. So first thing we are supposed to find in alternating current, since the electron is not moving, what it is doing, it is performing a to and fro motion. So what we are supposed to find first will be the average current for full cycle and for half cycle for different values. Okay, so average value for full cycle. So okay, so again I is equal to q by t, and previously we have seen the value of q is equal to integration of 0 to t I dt upon dt from 0 to t. Okay, so I is equal to again I naught sine omega t dt 0 to t upon 0 to t dt. Again, what we have studied, that sine omega t, the average value of sine omega t for full cycle will be 0. Hence, this value will become 0. So the average value for full cycle will always be 0. Pause the video and write these equations. Okay, so the average value is 0. Why? Because we are, that is involving sine omega t. Okay, so for half cycle, again I for half cycle. Again, for half cycle, what will happen? The instead of taking 0 to t, will consider only the value of 0 to t by 2. Okay, 0 to t by 2. I naught sine omega t dt upon 0 to t by 2 dt. Okay, q by t, this is the value of q, this is the value of t. Okay, so for half cycle, again for half cycle what will happen? Sine omega t, the value of sine omega t for half cycle will be something 2 I naught, this whole value will become 2 I naught by pi, 2 I naught by pi. So this is the average value of current for half cycle. Okay, so in full cycle what is happening, it involves the sine wave, positive and negative both symmetrical, that's why it becomes 0. Okay, for full cycle. And for half cycle it becomes something 2 I naught by pi, or approximately it, the values 0.637 I naught. Okay, in alternating current we are supposed to study average values, and after that we study the RMS value. So before going to jumping to RMS value, we study the setup of a resistance or heat generated by a resistance. Okay, so suppose we are flowing, it is flowing a DC value. So we have applied a thermometer, we have mounted a thermometer on this, and one value in other apparatus we mounted a thermometer, same value of resistance here, same value of resistance here, for same value of time, for same value of time. Here it will be AC current, or you can say I average. Okay, so what will happen? The temperature will raise. If the whole apparatus was on 0 degrees Celsius, then temperature will go from 0 to theta 1 degree Celsius, and the temperature will go from 0 to theta 2 degrees Celsius. Okay, so for finding this, the in practically we found that the theta 2 will be greater than theta 1. It means the heat generation in AC will be greater than the heat generation in DC, heat generated in DC, the temperature. Okay, second thing will be I RMS. So what is IRMS? This is called root mean square. So it means the summation of square values and then mean of square values. We will found consider the all square values, mean of that, and then under root of that. Okay. So for finding the RMS value, we do under root. First we do I naught square sine square omega t and the average of this squared value. Okay. So now you understand the square of the average of sine square as we have you have noted down. So this will be I naught square and the average value of sine square omega t will be 1 by 2, 1 by 2. So this will be something I naught by root 2. So this is I RMS. So this is also called I effective. Effective current, or in the same way we say that an effective voltage will be the same. Effective voltage will be V naught by root 2. The same heat generation done by DC. Okay. Now it is we will study one more thing, form factor. Form factor is what we can say that wave shape factor. Wave shape factor. Okay. Wave shape factor, how the shape of wave will be. Okay. So wave shape factor, this is called IRMS upon I average. Okay. IRMS, so form factor is IRMS upon I average. IRMS is I naught by root 2 and this is 2 I naught by pi. Okay. So this value I naught will be cancelled out. It will be pi by 2 root 2. Okay. Or simply you can say this is 1.1 approximate value. This is form factor for AC. Consider some questions. P1. Suppose this is 3 ampere. Okay. And another consider 4 sine 100 t ampere. So you are supposed to find net current, I average and I RMS. These three values you are supposed to find. Find it. Pause the video and solve this question. So now what will happen? Here simply if you are supposed to write I will be equal to 3 plus 4 sine 100 t. Okay. But now if you are supposed to find I average, how you will find I average? So what is I average? It will be the average value of I, again the average value of this. Everywhere you will not apply formula, simply you will write this. Okay. So for this, the average value of this you will write 3 plus 4 sine 100 t. Okay. The average value of 3, the simple average value of this number will be 3 only. Okay. 3 plus the average value of 4 sine 100 t will be 2 I naught by pi. So 2 into 4 by pi. It will be something 3 plus 8 upon pi. This is the average value. But when we are supposed to write RMS value, see IRMS is what? As I told you, the square of I and the average, and after finding the average it will be under root. So what will be the square of this? Write the value of I from there. T plus 3 plus 4 sine 100 t square of this. Okay. So it will be under root 9 a square plus 16 sine square 100 t a square plus b square plus 2 into 4 3 is 12 sine 100 t, and average of all this value. So as I told you boys, average of sine omega t will be 0. Okay, hence this value will become 0, and average of sine square omega t, the average of a square value of any trigonometric ratio will be 9 plus 16 by 2. Okay, remove this because you got the average. 16 by 2, this will be I RMS, something 18 plus 16 by 2, and under root this will be the RMS value. Okay, one more question you are supposed to solve. P2 3 sin omega t, 4 sin omega t, and find, you are supposed to find IRMS only. Okay, just pause the video and solve this question. For finding RMS, we are supposed to find I is equal to RMS. RMS is equal to what? The average. First, you are supposed to I square, square of I, and average of I square, and then you are supposed to find the root of that value. 3 plus 3 sine omega t plus 4 sine omega t, square of this, average, and root. Okay, so 9 sine square omega t plus 16 sine square omega t plus 2 into 3 into 4 sine omega t cos omega t. Boys, this will average of this value. Now as we know, the average of sine square omega t will be 1 by 2, the average of sine square omega t will be 1 by 2, and then average of this will, this value will be something 2 sine omega t cos omega t. It will become sine 2 omega t, and whatever this value will be, the average of this will be 0 only. So this term will become 0 after getting the after finding the average. This will be 9 by 2 plus 16 by 2 and under root. Okay, that's all. Square, the average of this is 1 by 2, average of this is 1 by 2. It will be something 25 by 2. It means 5 by root 2. This is IRMS. These are the simplest question which will be asked to find the RMS value and in the given circuit, or given current flowing wires. Okay, so we will simultaneously we will all solve the questions so that we have the good insight of topic. Okay, so that's all about current, basic things about alternating current, and we learned three values: average value in full cycle, average value in half cycle, and RMS value. Okay, so we are supposed to keep these values and these equations in our mind. Now next thing will be resistor in AC. Now application of circuits, application of three components. Three basic components are resistor, capacitor, and inductor. Okay, so all these three components will apply. First single components, and then we will apply the combination. Okay, so first we will study the resistor in AC. So now this is resistance, this is AC source. Okay, this is AC source, so the V will be, input voltage will be V naught sine omega t. Okay, again, so what will happen? So this is a stable resistance, so I is equal to V naught sine omega t by R. Okay, so as you can see, this is the peak current I naught, and R is what? Constant. Okay, so in every circuit or in every alternating circuit, we are supposed to find three things: the wave equation, first thing; second thing, phasor diagram; and third thing is wave diagram. Okay, so what we are supposed to find in phasor diagram again? So this is r is always constant, hence we can say that first phasor diagram, this is v and this is I. Why I is less than V? Because we have to divide R in V in order to find I. Okay, and wave diagram, and this is frequency independent. Okay, independent of the frequency, the no involvement of frequency. Why? Because resistance is constant. Okay, so wave diagram. So if this is this is voltage, this is voltage, and this is current. Okay, so this is wave diagram. Okay, time axis. So these three things we are supposed to find: wave equation. So we got the equation now, that I is equal to V is equal to V naught sin omega t. I is equal to I naught sin omega t. Since omega t is same, so phase, this will be in phase, same phase, frequency independent, and the phase is same for both. Next will be capacitor in AC. Now we will remove the resistor and we will apply the capacitor in AC. And one more thing is there, the average power of capacitance, average power of AC circuit. So P average will be average of V into I. Okay. Now what was V? Voltage was V naught sine omega t, and I was I naught sine omega t. Okay. So what will happen, students? This will be V naught I naught sine omega t. It will become sine square omega t, sine square omega t. Okay. So now the average value of sine square omega t will be 1 by 2 V naught I naught by 2. We can write it V naught by root 2 I naught by root 2. Okay. What was the value of V naught by root 2? Recall it. It was the RMS value. So we can write VRMS into IRMS. Okay. So this is the average value of power in the AC circuit where the capacitor is applied. Okay. So every time, since power involves V and I both the components, hence we can say that this is a permanent resistance. Why permanent resistance? Because the resistance was always applied. Okay, in power we are also getting the power, V naught and I naught both are involved, so the resistance is permanent. It means throughout the circuit, throughout the operation, it will uh, apply some resistance on the circuit. Okay, now next thing will be capacitor in AC. Capacitor in AC. Okay, so now draw this is source, one capacitor is applied, so V is equal to V naught sin omega t. Okay, now what we will do the next, in this circuit we are supposed to find the current. Okay, so in capacitive circuit what happens, we get charge, Q is equal to C V naught sin omega t. Okay, so what is I? I is equal to dq by dt. Okay, so for finding the I, dq by dt, so c is constant, it will be taken as common, v naught will come outside, sine omega t, again d sine omega t by dt. What is the differentiation of sine omega t? You will see c v naught omega cos omega t. Okay, again this c and omega can be written as v naught by 1 by omega c cos omega t. Since now we say we can see the difference between sin omega t and cos omega t. Okay, so what we can write instead of cos omega t? We can write v naught 1 upon omega c. This 1 upon omega c can be termed as xc, or capacitive reactance. Okay, cos omega t can be written as sine omega t plus pi by 2. Okay, so again we can write these two wave equations. I is equal to this v naught by xc. This can be written as v naught by xc, can be written as I naught sine omega t plus pi by 2. Okay, so now this xc is what? 1 by xc is what? 1 by omega c. It means as soon as, write this, I will use the whiteboard for writing the next part of equation. Now xc is what? xc is 1 by omega c. It means what? As soon as the omega will increase, okay, when omega will increase, the xc will decrease. Okay, it means if omega will be lesser, xc will be greater. So what we'll do, so we can draw a diagram like this. So if this is omega on x-axis, xc on y-axis, how this diagram will be? Like this. Okay, so we say that the capacitive circuit, capacitor we use in AC for high pass frequency. Okay, it means the frequency, higher the frequency, lower the reactance. Okay, so what we want, what is desired thing, we need or we want the less reactance or the less resistance in any circuit. Okay, so for high pass frequency, when omega will become higher, this xc will be lesser, it will decrease. So we need it for, we want this circuit for high pass frequencies, we use this circuit. Okay, and in the same way you can say that the resistance is what? Resistance is not permanent, resistance is temporary. Okay, again first thing, the phasor diagram. Phasor diagram, for phasor diagram what we do, you can say v naught sine omega t, and this is v I is equal to I naught sine omega t plus pi by 2, or we can say the current lead by 90. I lead by 90 degree from V. Okay, current leads 90 degree by voltage. Okay, so in phasor diagram we will always draw voltage on x-axis. Okay, so the current is leading, so if something is leading, what will happen? It will go anti-clockwise. Okay, so here it will be drawn current. Okay, so current is leading, voltage is lagging, or we can write the same language, voltage lag by 90 degree from current. Okay, this is phasor diagram. Next thing will be, so what will happen for the wave diagram, students? बच्चों, uh, again for wave diagram, this is the, if we draw it like this is the voltage. Okay, and now if we'll draw current, so current is leading, so the leading value will be start from here. So this is current. Okay, so this is current, this is voltage, this is the phasor diagram. Next thing what we are supposed to find out is, pause the video and write everything, don't move fast as me. Next is average power. So P average, again what will be average power? The multiplication of voltage and current, V I. Okay, so now V is what? V naught sin omega t, and I is what? I naught cos omega t. Okay, so average of this, as you know, the sin omega t and cos omega t will become something sin omega t by 2 something. Okay, so whatever will be the average, if it becomes a square we'll get the average 1 by 2, but if these values are not a square, it will be something, the formula of sin 2 omega t, sin omega t by 2. Okay, so this will be 0. So the average power is 0. What does it depicts? Average power means it is temporary resistance, and what? Wattless current. Okay, this is important term, remember it. Wattless current means the current is flowing, circuit is working, but the average power of circuit is 0. Okay, so the capacitive circuit is in AC is always gives us wattless current. Okay, in previous circuit when the resistance was applied, you have seen that we were getting some value of average power. It was Vrms into Irms something. Okay, V naught I naught by 2, but in this case we are getting wattless current. Okay, now again we will apply. First component we have studied resistance, second component we have studied capacitor, third component we will study inductor. Okay, inductor in AC. Okay, now what is inductor? It means when the current will start growing, it will oppose the growth. When current will start flowing in other direction, it will again support it, it will again oppose the growth and support the decay. Okay, this is the function of inductor. So V is equal to V naught sin omega t, this will be input. Okay, so now if we are supposed to find the current, what? V is equal to, in terms in case of inductor, L di by dt. Okay, so if we are supposed to find the current, what we'll have to do? V dt by L is equal to di. So integration, again V is equal to V naught sin omega t dt by L is equal to I. Okay, V naught sin omega t dt by, it will be something, V naught after integration cos omega t by L omega, it will be current. Okay, so this value will be I naught. Okay, so I naught is what? Again note it down. I naught will be V by L omega. So this L omega is what? Is the equivalent value to resistance. We'll write this XL, or inductive reactance. Okay, inductive reactance, its diagram will be something, omega and XL, it will be linear. So now see students, again XL is equal to L omega. So as omega will increase, here it is XL is directly proportional to omega. as omega will increase, XL will increase. So will we use this circuit for high pass frequency? No, because high pass frequency the XL will become very much higher value. So we use it for low pass frequency. Okay, so we use this for low pass frequency. Why? Because XL is directly proportional to omega. Okay, and the value of I become I is equal to I naught. So for the value of cos omega t, now we can write sine omega t minus pi by 2. Okay, it means now the current is lagging pi by 2 from voltage. Okay, so voltage lead by 90 degree and current lag by 90 degree. Okay, so what you can write, how you can draw the diagram of this. So phasor diagram, for phasor diagram first see the phasor diagram. So voltage will always drawn on x axis, this is voltage. Okay, now current is lagging, so which is lagging, it will be on this side current. Okay, okay, wave diagram, wave diagram and phasor diagram both depends upon these equations only. Okay, now draw current, this is I. Okay, now next we are supposed to draw, since voltage is leading. Okay, so which is leading, it will be start from here. Okay, like this is voltage. Next, one more thing remaining in this is average power. Again, average power will be P average is equal to V I. Again, what is V, students? V naught sin omega t, and it will be something I naught cos omega t. Okay, again multiplying this, it will not get any square value of the trigonometric ratios, so we will get average power as 0. Again, it is also temporary resistance and wattless current. Okay, so that's all about the alternating current basics and three circuits. In the next class we will study the combinations of alternating currents of various these three components. Okay, thank you so much. Thanks students for